What exactly are systems of linear equations, and why do they matter? Imagine a puzzle where each piece is an equation, and together they reveal hidden insights. Today, we'll explore this fascinating world, starting with these simple equations. X plus y equals 100, and x is greater than or equal to 60. These lines might seem abstract, but they are the keys to solving real-world problems. Visualize a graph where these lines intersect, and you'll uncover solutions, tangible outcomes. In this journey, we'll see how such systems can power decisions, from business to design. Imagine deciphering a system of linear equations like solving a puzzle. Here we have two key pieces: one equation, x plus y equals 100, and a graph to help visualize solutions. On the graph, a line represents all combinations where this equation holds true. Next, consider a constraint. X must be at least 60. We plot this as a vertical line. Where these lines meet reveals the solution. We've just pinpointed the exact values that satisfy both conditions. Isn't that an elegant way to see the solution? Imagine you're managing a coffee shop and have to choose between two coffee bean suppliers. One offers Arabica at $5 per unit and Robusta at $3 per unit, while the other provides Arabica for $4 and Robusta for $2. Naturally, you want to minimize costs. Let's represent Arabica as the variable x in blue and Robusta as y in gold. First, we explore supplier 1. The equation 5x plus 3y means every combination of x and y gives a total cost for that supplier. For supplier 2, the equation changes slightly to 4x plus 2y. Different numbers, same concept. Now envision these cost equations graphed, forming lines that depict the constraints. As we analyze these, we're seeking the optimal point, a beautiful harmonious solution where x equals 60 and y is 40. But how do we know this choice is best? By substituting. The numbers satisfy our equations. Voila! A cost-effective decision for your coffee shop is made. We've reached the end of our exploration into solving systems of linear equations. By combining algebraic equations with graphical analysis, we uncover solutions that satisfy all conditions. Two intersecting lines on a graph reveal the answer, a harmonious point where algebra meets geometry. Here, the solution speaks for itself, 60 and 40. This approach helps visualize complex problems, highlighting the power of mathematical collaboration. As we move forward, embrace these insights and let them guide you through new mathematical challenges. Until next time, continue your journey of discovery.